Our solar system is dominated by a celestial giant, the Sun. This yellow dwarf star, a massive ball of burning gas, dictates the rhythm of our planets and moons. The Sun's immense gravity holds everything in our solar system in its grasp, from the smallest asteroids to the mighty gas giants. The Sun is about 4.6 billion years old, roughly middle-aged in star terms. Its sheer size is difficult to comprehend. With a diameter of 1.4 million kilometers, it could comfortably accommodate over 1 million Earths within its volume. The Sun's mass is staggering, approximately 333,000 times that of Earth. This tremendous mass generates a gravitational pull that defines the orbits of all objects in our solar system. The Sun's surface temperature averages around 5,500 degrees Celsius. This scorching heat is a mere whisper compared to the inferno raging at its core, where temperatures reach a mind-boggling 15 million degrees Celsius. This extreme heat is a byproduct of the nuclear fusion reactions that power the Sun and bathe our solar system in light and warmth. Understanding the Sun is about more than just astronomical curiosity. It's about comprehending the very forces that sustain life on our planet. The Sun's energy drives our weather patterns, fuels photosynthesis, and shapes Earth's magnetic field, making it the undisputed powerhouse of our solar system. The Sun may appear as a uniform ball of fire, but it's a complex and dynamic structure. Scientists divide the Sun into several distinct layers, each with unique characteristics and roles in the Sun's overall function. At the heart of this celestial powerhouse lies the core, the Sun's nuclear furnace. Here, under unimaginable pressure and heat, hydrogen atoms fuse to form helium, releasing tremendous amounts of energy in the process. Radiating outward from the core is the radiative zone, where energy slowly travels in the form of photons. These photons can take hundreds of thousands of years to traverse this dense region. Above the radiative zone lies the convective zone, where energy is transported through the churning motions of plasma. Think of it as a boiling pot of stellar material, with hotter plasma rising to the surface and cooler plasma sinking. The Sun's visible surface, the photosphere, is a thin layer that emits the light we see. This layer is also where sunspots, cooler, darker regions caused by magnetic activity, appear. Above the photosphere lies the chromosphere, a thin layer of the Sun's atmosphere visible during solar eclipses as a reddish rim. The outermost layer, the corona, is a vast, extremely hot region that extends millions of kilometers into space. The Sun's structure, a delicate balance of gravity, pressure, and nuclear reactions, is a testament to the elegant forces that govern the universe. Understanding these layers provides invaluable insights into the Sun's energy production, its dynamic behavior, and its influence on our planet. Deep within the Sun's core, a process of unimaginable power unfolds: nuclear fusion. This process, the engine that drives our star, involves the fusion of hydrogen atoms into helium, releasing colossal amounts of energy in the process. Imagine billions of hydrogen bombs exploding every second. That's the scale of the Sun's energy production. The Sun's core, crushed under immense pressure and heated to unimaginable temperatures, becomes the perfect environment for nuclear fusion. Here, hydrogen atoms, stripped of their electrons, are forced together with such force that they overcome their natural repulsion and fuse. This fusion process releases a tremendous amount of energy in the form of light and heat. This energy, in the form of photons, then begins a long and arduous journey outward, first through the radiative zone and then the convective zone. It eventually escapes the Sun's surface as sunlight, bathing our solar system in its warmth. This energy, the lifeblood of our solar system, is the driving force behind Earth's climate, the engine of photosynthesis, and the source of the solar wind that shapes the environments of planets and moons. The Sun's nuclear fusion is a delicate dance of immense forces, a process that has sustained life on Earth for billions of years. It is a testament to the universe's ability to create and harness unimaginable power, a power that continues to shape our solar system. Section 4. The Sun's temperament. Sunspots, flares, and eruptions. The Sun may appear calm and constant from our vantage point, but it is a celestial body teeming with activity. This activity, driven by the Sun's powerful magnetic fields, manifests in various phenomena, some subtle, some intensely powerful. Sunspots, those dark blemishes on the Sun's surface, are a visible reminder of the Sun's restless nature. These cooler, darker regions are caused by intense magnetic activity that inhibits the flow of heat from the Sun's interior. Solar flares, sudden bursts of energy and radiation, are another dramatic display of the Sun's power. These eruptions, often associated with sunspot regions, release vast amounts of energy in the form of light, heat, and charged particles. Coronal mass ejections, or CMEs, are even more powerful events, launching billions of tons of solar plasma into space. Imagine a billion-ton cannon firing into space at millions of kilometers per hour. That's the scale of a CME. These solar storms, while visually stunning, can have significant impacts on Earth. Intense solar flares and CMEs can disrupt radio communications, interfere with satellites, and even pose risks to astronauts. Understanding and predicting these events are crucial for protecting our technology and spacefaring endeavors. The Sun's dynamic nature, while potentially disruptive, is a reminder of its immense power and the complex forces at play within its fiery depths. These events, from subtle sunspots to powerful CMEs, provide valuable insights into the Sun's behavior and its influence on our technologically dependent world. Section 5. The Sun's reach, Earth's climate, life, and magnetic shield. The Sun's influence extends far beyond its visible disk, shaping the very environment of our planet. It's easy to forget that the light and heat we receive from the Sun are the very essence of life on Earth. The Sun's energy drives our weather patterns, warms our oceans, and fuels the process of photosynthesis, the foundation of most life on our planet. Without the Sun's energy, Earth would be a frozen, lifeless world. The Sun's energy, absorbed by Earth's surface, drives the atmospheric and oceanic currents that regulate our climate. It's the engine behind the water cycle, the wind patterns, and the very air we breathe. The Sun's role in photosynthesis is equally crucial. Plants, algae, and certain bacteria have evolved to capture the Sun's energy and convert it into chemical energy, releasing oxygen as a byproduct. The Sun's influence extends beyond energy, shaping Earth's magnetic field, our shield against harmful radiation. The solar wind, a constant stream of charged particles from the Sun, constantly bombards our planet. Earth's magnetic field, generated by our planet's molten core, acts as a shield, deflecting most of this harmful radiation. The interplay between the solar wind and Earth's magnetic field creates the beautiful Aurora Borealis and Aurora Australis, visible reminders of the Sun's constant presence in our lives. The Sun, our nearest star, is not merely a celestial object. It is the lifeblood of our planet, shaping our climate, driving our biosphere, and protecting us from the harsh realities of space.